It'll be coming up in a second. I'm just in the YouTube thing. All right, welcome again. So again, as I said before, our topic is all about making soluble salts. And you already learned how to make an insoluble salt. I hope it has been drilled into your mind and cemented in there, and you are fully aware of how to make an insoluble salt. So today we're going to talk about how do you make soluble salts? And I just want you to remind me, I'm going to tell you a list of salts, and I want you to tell me if those salts are soluble or insoluble, right? And the only way you will know that is if you have been studying and remember the solubility rules. All right, so potassium nitrate, is that a soluble salt or an insoluble salt?
Soluble, miss.
It's soluble. Why? Tell me the rule.
It's all spa elements are soluble.
Right, and also all nitrates are soluble as well, right? Excellent, excellent. All right, you guys, you're on the right track. All right, what about this one? Sodium hydroxide.
Insoluble, miss.
Sodium hydroxide.
It's soluble because it's a spa element.
Right, because sodium, potassium, ammonium, you remember spa? All of those are soluble no matter what, no exception. So sodium, anything with sodium in it is always soluble. All right, what about lead sulfate? Lead sulfate.
Insoluble, miss.
Insoluble, why? What's the rule?
Miss, because most sulfates are soluble except for lead and barium.
Very good. All sulfates are soluble except for lead and barium. And the final one I'm gonna give you is zinc carbonate. Zinc carbonate. Soluble or insoluble?
Insoluble.
Insoluble, very good, because all carbonates and phosphates are insoluble except for group 1 metals or sodium, potassium, ammonium. All right, so very good. So you're on the roll, you're on the ball with the solubility rules. So today we're going to talk about preparation of soluble salts, and there are really 3 ways that you can prepare soluble salts, 3 ways that you can do it. The first way is called direct combination. So I'm gonna show you the textbook because that's the only thing we can work with for today. And hopefully you can see it. Are you seeing it? Oh no, it's mirroring. It's mirroring. Can you see it? Is it backwards?
No, miss.
No, miss, it's just blurry.
Oh, it's blurry. Hold on.
Miss, I can see it.
You can. So how come I'm seeing it backwards? All right, here we go. How about that? So there are 3 main methods to prepare soluble salts. Are you seeing it properly now?
Yes.
Not really, miss, but you can dictate it.
All right, so again, the first way is direct combination, and we're going to talk about what that is in a moment. The second way is when you react a reactive metal, an insoluble carbonate, or an insoluble base and an acid. The third way is when you have a soluble base called an alkali and an acid, and we use that method called titration. So the first is direct combination. The second is when you react a metal, insoluble carbonate, insoluble base, and acid. And the third is when you react a soluble base and an alkali, or an alkali, which is what a soluble base is, and an acid.
Miss,
So
I'll
let's
be
start.
honest, I'm not going to remember all of that.
That's okay. I'm going to send you this information so you can have it as notes. All right. So the first way that we're going to talk about is direct combination. Now, who can tell me just from the name, what do you think direct combination is?
Miss, where you directly combine two soluble salts?
Yes. Now, it's not directly combining two soluble salts. What you are directly combining is two elements that will make a soluble salt. Do you understand? So let us look over here at an example. Now, we are going to try to make the soluble salt aluminum chloride. This is a soluble salt, aluminum chloride. So tell me the two elements that you will combine to make aluminum chloride.
Miss,
Aluminum and chlorine.
Very good. You would take aluminum and you will take chlorine and combine them. So that is what direct combination is all about. So this is what we call a fume cupboard, right? Or a tube that, sorry, a room or tube or cupboard that you release gases inside, and chlorine is a very poisonous gas, so you don't want to do this in the open air. So you have your fume cupboard here, and you have a tube that passes chlorine gas inside. You also have some aluminum foil. And so you have your aluminum and you have your chlorine gas. You pass it inside and the two will combine to give you aluminum chloride. Now, what is also great about preparing this salt in this way is that it is anhydrous. Who can tell me what anhydrous means?
lacking water.
No water, absence of water. So if you notice, you're just taking the gas and you're taking the metal and combining them. There is no water present. It is not aqueous, right? As a result, you will get an anhydrous salt, a salt that contains no water. Is that clear?
Yes, miss, that's kind of what I said.
So you can produce a lot of soluble salts this way by just taking the two elements, putting them together, and you get the soluble salt. And this method is called direct combination. Now, scientists typically use direct combination when you want to prepare an anhydrous salt. They use direct combination when you want to prepare an anhydrous salt, meaning absence of water. Is that clear to everyone?
Yes, miss.
All right, now we're going to move on to reaction with acids. Now, you can also take a metal, an insoluble carbonate, or an insoluble base and react it with an acid. Once you do that, you can also get a soluble salt. So let us look at this first example. In this example, they have magnesium and they have hydrochloric acid. What is the name of the salt that will be produced when you have magnesium and hydrochloric acid?
Miss, magnesium chloride.
Very good. You will get magnesium chloride, and that is a soluble salt as well as hydrogen gas. Now, why is it that you cannot use this method to prepare potassium, sodium, or ammonium salts? The reason is because those metals are too high in the reactivity series. So remember that for potassium and sodium, when you react it with even water, what happens? It reacts very violently, explosively. So you can imagine if you would take potassium and sodium and put it in an acid, what you think would happen?
Kaboom!
You wouldn't be there to collect any salt. You would have to go far, far away and run away from that explosion. So if you notice, you want to prepare a soluble salt, but you cannot prepare potassium or sodium salts using this by just taking the raw metal and reacting it with the acid because it is too violent. So you have to use metals that are lower in the reactivity series. Is that clear?
Yes, miss.
Now, another thing that you can react with acids is the carbonate. So you take an insoluble carbonate, and almost most carbonates are insoluble except spa. So you have calcium carbonate here, and you're reacting it with nitric acid. So calcium carbonate and nitric acid. Who can tell me what is the name of the salt?
Calcium nitrate.
Calcium nitrate. Excellent. And for those of you who didn't catch on to how you get the salt, please remember, I'm trying to focus this thing. Is it still blurry?
Yes, miss.
Okay, here we go. Please remember that when you thing. Okay. Please remember that when you have a carbonate or a metal or anything coming in contact with the salt, with the acid like this, what will happen is the metal is going to displace the hydrogen and take the place of the hydrogen, and then you will get the salt. So for this one, the magnesium goes in and takes the place of the hydrogen, and that is why you get magnesium chloride. And for this one here, the calcium will go in, take the place of the hydrogen, and that's why you get calcium nitrate. All right. And the last way is from these three is taking an insoluble base like copper oxide. And again, the copper is going to displace the hydrogen. And who can tell me the salt that you are going to get?
Miss copper sulfate.
Copper sulfate, very good. So you're going to get copper sulfate as your salt, and that is also a soluble salt because all sulfates are soluble. So you have two ways, as I told you before, just now. We spoke about direct combination when you take the two elements and you combine them and you get your salt, but you only use that if you want an anhydrous salt, meaning without water. The second way is to react with acids. What are you going to react with an acid? You're going to react a metal with an acid, but you cannot use potassium or sodium. Who can tell me why? Why can't you use it?
Miss, they're too high on the violent something charts. Miss,
They're
they're
too
too
high in
violent.
the reactivity
Yes, miss.
series. Right. So in the reactivity series, they are high up, meaning that they react violently with an acid. And so you will have to use metals that are low in the series. You can also use a carbonate or a base, and both have to be insoluble. Is that clear? No.
Yes, miss, but I have a question.
Go ahead.
What will happen if it's soluble?
Okay, if it is soluble, what is going to happen? And I'm going to show you the method of using it. But if it is soluble, we have another method. We have another method of reacting the two. Now, let me just show you how you're going to do it. I'll show you the picture. So The reason why you want it to be insoluble is because you want it to be solid. You don't want it to be aqueous. You want it to be solid so that you can do this method. So the first thing you do is you are going to take your insoluble base or insoluble carbonate or metal, and you're going to add it to your acid. So in this case, they're preparing copper sulfate. So they have copper oxide, which is this black stuff here, and they're placing it and stirring it inside the acid. Is that clear?
Yes, miss.
Miss.
All right. Now, the second thing is they are going to now filter off the excess. Now, if it was soluble, there would be nothing to filter, right? But it's insoluble, so you have to filter off the excess. Then you heat it and cause the water to evaporate, and you will get your crystals. Very easy, very simple. So the first thing you do is you take your metal, your carbonate or your base, must be insoluble. You stir it, heat it up, then you filter off the excess. Finally, you take your filtrate and you heat off the water, and you will get your soluble salt. Clear?
Yes, miss.
No.
Yes, miss.
If it is, remember that for this method, you cannot use potassium, sodium, or any soluble salt, any soluble base or carbonate. Now, if you have SPA, potassium, sodium, or ammonium salt, you cannot use this way. Why? Because potassium and sodium are too high in the reactivity series. So you have to choose another way. And this final way is called titration. What is it called?
Titration.
Titration.
No. What is titration all about? Well, you do the same thing. You take your potassium, so you want to produce a potassium salt, like potassium sulfate. So you have to use potassium something. So you can use potassium hydroxide or potassium carbonate. And then you're going to add it to your sulfuric acid. And then you will get your potassium sulfate. So this is how titration works. You're going to take your base and you're going to put it in here, which is your potassium hydroxide. All right. And then this is called a conical flask. Once you place your potassium hydroxide in your conical flask, then you are going to take this other instrument, which is called a burette, and you're going to place your sulfuric acid in it. When you add enough acid, that will cause all of the potassium hydroxide to be used up, and you get only potassium sulfate, then you stop adding acid, and you will get your salt, your soluble salt. Is that clear? Now, this reaction is very tricky. Why? Because all of your liquids are clear. How will you know if you've added enough acid to cause all of your potassium hydroxide to react? In order to know that, you will have to use something that is called an indicator. An indicator will change color when all of it is used up. Once the indicator changes color, then you know that you have reached the end of your reaction. That is what we call a titration. And you have to do it more than once in order to come up with the right amount of acid that you need to add. All right? So let us just review what we've done so far. We've spoken about 3 methods. The first is direct combination. You use this when you want to produce an anhydrous salt. The second way is to react with an acid. What are you reacting with an acid? You're reacting a metal, an insoluble carbonate, or an insoluble base. And can you just use any and any metal?
No, miss.
No. You only can use metals that are
Low
low
on the reactive something.
reactivity series. Say it so you can remember it.
Reactivity series.
Very good. And what you do is you take your metal or your carbonate or your base and you mix it with your acid. You filter the excess. Then you take the filtrate, heat it up, and separate of the water so you get your crystals, your salt crystals. All right. And the third and final way is a method called titration. This is when you take your base, put it in a conical flask, add your acid from a burette, use an indicator to tell you the exact amount of acid you need to add, and then you will produce your soluble salt. You mainly use this method, titration, with sodium, potassium, or ammonium salts. You only use this method called titration with which kind of salts?
Sodium, potassium, and ammonium salts.
Very good.
Miss, I have a question.
Go ahead.
Miss, so when you're making a soluble salt, Miss, do you dry it out like when you're making an insoluble salt?
Oh, yes. But the thing with soluble salts is because it is soluble in water, you can get crystals because not all the water will evaporate. The water will form a crystalline structure with the salt, and you'll get these beautiful crystals. And we are actually, if we ever go back to school, we will get the chance to make copper sulfate crystals, which you can get a beautiful blue color.
Ooh, I like blue.
All right.
I have questions.
Go ahead.
Miss, when you filter off the excess, is the excess metal that is left in the
Right. Because you're adding a lot because you want the maximum amount of, you want all of your acid to be used up, right? So you have to over add.
okay.
You have to add a lot of it, right? Okay. So let's summarize now, and then I want you to go to Google Classroom and do an activity. So when you're making a salt, you have to ask yourself this question. Is the salt soluble in water? Are you still seeing the screen?
Yes,
Yep.
miss.
Yes,
All right.
Miss, kind of blurry.
All right, so when you're making it, is the salt soluble in water? Do you want a soluble salt or an insoluble salt? If it is not soluble, you're going to use ionic precipitation, which we've spoken about, right? You take 2 soluble salts and you mix it to get your precipitate. Clear?
Yes, miss.
Now, if the salt is soluble, you're going to have one of 3 ways: direct combination, reaction with acids, or titration. So you have to first narrow it down now. So you're going to ask yourself, is the salt SPA? Is it sodium, potassium, or ammonium? If it is, then you have to use titration, because again, you only use titration with the SPA, usually with the SPA salts, right? Is that clear?
Yes, miss.
Yes, miss.
If it is not SPA, you're going to ask yourself, do you want it anhydrous? If you want an anhydrous salt, yes, you use direct combination. If not, then you use the metal, the insoluble carbonate, or base to make your salt. So you have now learned 4 ways to make a salt: ionic precipitation, titration, direct combination, or using reacting metal, carbonate, or base with acid. I wish they had like a cool name for this long one, but they don't. But they just have a description. So again, ionic precipitation, this is for making insoluble salts.
Miss, we can call the long one the long one.
The long one. Titration, direct combination, and the long one. All right? So now, what I'm going to be doing is I'm going to be asking you a few questions in order.
Miss, you're muted.
All right, so what I'm going to be doing is I'm going to be asking you a few questions to ensure that you understand what I'm saying. Can you see me?
Yes.
Yes, miss.
Yes,
All right,
miss.
excellent. All right, so first things first. I want you to first tell me what is, if this salt is soluble or insoluble. Magnesium chloride. Let me ask somebody who has not participated yet. I haven't heard from Rave, I haven't heard from Akil, and I haven't heard from Joshua. So one of you guys, can you tell me magnesium chloride, is it soluble or insoluble?
Insoluble.
That is not correct. So all chlorides, bromides, and iodides are soluble, except lead and silver. So magnesium is soluble, all right? No, so you know now that you're making a soluble salt, magnesium chloride. So I want you to tell me, which method would you choose to make magnesium chloride? Which method would you choose? Hello?
Miss, could you repeat that question, please?
Yes. Sorry, it's not COVID. Give me a moment.
I was just about to say, Miss.
I just need a glass of water. Hold on. Just a second. Just find some water somewhere.
Miss, you know that other animals probably make jokes about humans.
Like, that's a what?
Like leave it to a human to choke on dry air.
It's not dry air. It's
Of
wet air.
course, Miss, it can be wet or dry sometimes. I think I don't know.
There's a fluid.
All right, so let's get back to it. So we have magnesium chloride, and I'm going to write it down so you can see it, and then we're gonna go through the steps. So, all right, so magnesium chloride. Oh man. All right, so you know that it looks like this, MgCl2. Now we're trying to figure out how we're going to prepare it. Now, there's no anhydrous in front of it. So remember, we have 4 ways to prepare a soluble salt. We have ionic precipitation, we have direct combination, this thing. We have titration, and I'm just gonna call it reaction with acids. I know that is the long one, right? So the acid is going to react with a metal, an insoluble carbonate, or an insoluble base. All right, so those are the 4 ways. Now, if you don't want an anhydrous salt, which one can we rule out here that we don't have to use?
Direct combinations.
We don't have to use direct combination. We've also said that magnesium chloride is soluble. So which other one can we rule out?
Ionic precipitation.
Ionic precipitation. So this only leaves us titration and the long one. Now, magnesium chloride. Why can't it be titration?
I don't know.
Remember, I said to you that we usually use titration with SPA. And is magnesium chloride a SPA salt?
No, miss.
No, so we don't use it. So this is the one that we're going to use. Reaction of acid with a metal, insoluble carbonate, or insoluble base. So let us write a balanced chemical equation for the production of this salt. Who wants to choose what we use? Which acid will we use in the first place? Which acid must we use?
Hydrochloric acid.
We have to use hydrochloric acid because we need the Cl for the salt, right? And then we can use a metal. Which metal must we use?
Magnesium.
Magnesium metal. So we take the magnesium metal, we add it to the acid, we stir, we filter, and then we heat. And we get magnesium chloride. And what will be the other compound that is formed? Acid plus metal give you salt and
Hydrogen.
hydrogen gas. Very good. Is it balanced?
No.
No. What do I need to do?
Put a 2 in front of the H.
Put a 2 in front of the H. Very good. And now it's balanced.
Ooh, I got good at balancing chemical equations.
Yay. All right. Now we're going to look at this other one. Lead sulfate. Who can tell me, is that a soluble salt or an insoluble salt?
Insoluble, miss.
It's insoluble because all sulfates are
Or
soluble.
soluble except for lead and barium.
Very good. So lead sulfate looks like this. All right. All right. So it's insoluble. So only one thing we can use to make it. What method? One method we can use to make it.
Ionic precipitation.
Very good. The method is ionic precipitation. And in ionic precipitation, you're going to take 2 soluble salts and make your insoluble salt. So tell me, one of the salts must contain the cation or lead, and the other salt must contain the anion or sulfate. So tell me 2 salts I can use.
It's lead nitrate.
All right, so you're good. You're very good. You're choosing a nitrate because all nitrates are soluble. They're going to use lead nitrate and something sulfate.
Sodium sulfate.
Sodium sulfate, because all SPA are soluble, right? And so what are my 2 products going to be? What are my 2 products going to be?
Sodium nitrate or sodium sulfate or something.
Look good. What am I producing? What salt do I want to make?
Oh, lead sulfate.
So you're going to get lead sulfate, and what is going to be the state symbol I'm putting beside it?
S.
S. Why?
Because it's now soluble.
Because it's insoluble. Right?
Sorry,
It's
miss.
a precipitate. And then what is the next salt that's going to be produced? So when you take out lead sulfate, what is left? Tell me, Ravi. Ravi, tell me. Where Ravi? Joshua, tell me, what are you going to get? You see, you take out lead sulfate, right? So what is the next salt that is left in there to be produced? Somebody tell
Sodium
me.
nitrate.
Sodium nitrate. Very good. Very good. Sodium nitrate. Is it balanced?
No,
It's not
miss.
balanced. What do I need to do?
2 in front of sodium, the Na.
Very good. And now it's balanced. So I'm using ionic precipitation, and this is the balance equation for it. Let's do 2 more. This one is called anhydrous iron 3 chloride. What method can I must use because of this word?
Direct combination.
I must use direct combination because direct combination is used for anhydrous chlorides. Direct combination. So what 2 elements am I going to combine?
Iron and chlorine.
Right, so I'm going to take a piece of iron. I'm going to run it with some chlorine gas. And I'm going to get iron 3 chloride. Balance it for me, please.
Miss, I can't see the thing properly.
How about now?
Yes, miss, that's better. Miss, it is definitely not balanced yet.
All right, what do I do?
Let's replace the 2 with a 3.
And I replace nothing.
How comes? Miss, is that a... Miss, you're messing up my eyes, you know.
Is it balanced now?
Yes, miss.
All right, so remember when you see a 2 and a 3, you just multiply the 2 by the 3 to get 6 and the 3 by the 2 to get 6. All right. Finally, the last one we're going to do is potassium nitrate. Potassium nitrate. So this is a spar salt. What method do you use with spar salts?
Titrate.
What method do you use? You use titration. And with titration, you just take,
Spa.
yes, sodium, potassium, ammonium. So with titration, you're going to take the hydroxide, which is the alkali, and the acid. So which acid must you use? Which acid must you use? Nitric acid. And which hydroxide must you use? Which alkali? Which alkali must you use?
Potassium oxide.
Potassium hydroxide, right? You can use potassium oxide to no problem. And then what are you going to get? What are you going to get, class? 2 things, salt and water. Tell me the salt.
The salt you'll get is potassium nitrate.
Most definitely, because that is what we're trying to get.
Yes,
Miss, and the water you get is H2O.
Very good. All right, now, is it balanced?
Miss, I don't know. I can't see it.
What happened?
Yes,
Miss, I think it's my Wi-Fi. It's probably slow.
Okay, so yes, it's balanced already, right? And that's the equation. All right, so for your activity, it is exactly this. The activity asks you to name the method. So you have to say ionic precipitation or direct combination or titration, etc. And then it asks you to tell the 2 compounds. So if you're going to use, lead nitrate and sodium sulfate, and you need to write a balanced equation, which I've done. So the activity is very similar to this. You go there and you name the method, name the 2 things you're going to use, and write a balanced equation.
Miss,
I won't worry about the suffixes and those things because I know that in Google Classroom it is hard to write it. So as long as it's all there, I'll still mark it right.
Miss, this is the activity, Miss. Miss, while you were doing,
Oh
while
yeah.
I was there typing on
Oh,
Google.
perfect. So then you're halfway there, right?
So I'll
So
submit in a few minutes.
all right. So I am going to be asking you to just take the last few minutes of class and finish it up because we have done the majority and just submit it to me. All right. And that will be your monthly assessment for the month of March. No, which month we in now? April.
Me,
All right.
miss.
Okay. Do you have any questions for me about what we talked about today? The 4
Miss,
ways to
it's me.
prepare salts. Any questions?
Miss will be sending those pictures to the class group.
Yes, I'm sending it to the class group now. So once I send it to the group, you'll be able to go and just read over. And you can also re-watch this activity on YouTube, like and subscribe to my channel. And so you can get the videos. All right.
Yes, ma'am.
All right, guys. So if there's nothing else, take care of yourselves. And I'm looking forward to the completed assignment today. All right.
Yes, miss. Bye,
Take
miss.
care, everybody. Bye.